Okay, the last couple lectures we have covered how to visualize some vector data, and for lab 7, create some of those functions, how to visualize vector data. And I will usually recommend that follow the lectures, try to type the source code by yourself. Don't just go to my repo and then copy and paste and then finish it in 5 seconds. You're not going to learn, okay? You need to type the source code. You can use GitHub Copilot, but I mean, it's beginner. I would highly recommend that you type the source code. You encounter the error, you fix it, gradually become much better. You can always come to a repo, copy and paste. It's not yours, okay? Until you are really good, you can go online and copy and paste people's source code and make some changes, become yours. But at your stage right now, I will not recommend. Okay, so unless you understand everything, even if you understand, I mean, this is not my memorizing. It's more important how you really think about how to conceptualize the problem and then turn it into source code. So try your best, spend some time and then practice. It should not be super difficult. The last resort is that you go to my repo, you take a look at what I did, and then you type yourself. I recommend that you just follow lecture, you type one by one. Don't just go copy and paste. So so we have covered how to visualize some vector data. There are not more, but today we're going to cover how to visualize raster data. Okay. So previously we have created this function. It doesn't really work yet, so we're going to redo it. And similarly, we're going to use IPyLeaflet. So first, let me show you. Go to IPyLeaflet. And I want to let you know that although IPyLeaflet is very powerful, but it's not very intuitive to visualize data if you don't know how to do it, especially for raster data. Because if you look at here, the layers, there's not really a layer class that's specifically used to visualize raster data. You can have tile layer, you can have an image layer, even for this one, like image services. There might be one called image overlay or something, image overlay and raster overlay. But this is not, technically, this is not visualizing geospatial data. This is more like visualizing, just put a non-geospatial data overlay on top of the map. For example, if you look at this one here, you can zoom in, you can zoom out. But this image itself is just like a simple PNG. And when you try to, for example, here, we can try this example just to show you how it works. And you can certainly also implement this one within your package if you want to. So just make it easier. For example, just give me a URL and then provide the bounding box, and then I can add that one to the map. So let me show you how to do that. I'm going to start with this one, non-spatial data, and then later I'm going to visualize spatial data. So before I get into that, I will always recommend, right, if you want to try something out, don't put it into a source code yet, unless you know what you're trying to do. So I'm going to go to my example here, and I'm going to create a new notebook so that I can create some raster functionality. I'm going to say raster.ipynb, okay? And then from here, I can just copy and paste the source code. There's a semicolon here. There's no needed for Python, so just remove it and then run this one, okay? And here, so it should work just fine. Then you can start integrating this one into a package, and I'm going to show you how to do that shortly. So this one here, import IPyLeaflet and then image overlay class. Then we're going to create an interactive map, then create a class. So IPyLeaflet allows you to add anything to the map. So for example, it can be a control, it can be a layer, it can be image overlay, it can be a logged things. So for this image overlay, you need to pass in a parameter. So this one you can pass in a URL to the HTTP to an image, and then you also need to pass the bounding box. The bounding box here, you're going to have 2 coordinates. So think about here, this would be lower left, upper right. So basically, min x, min y, x max, y max. So basically, we go back to the thing here. So when you're trying to add an image to the map, so you need to have 2 corners. So usually it will be this corner, the coordinate of this one, and then also the coordinate of this one. When you have those 2 points, the map will usually fix. Okay, so you need to have a map, basically an image that's a rectangle. Why it takes so long? way too much. So what we can do here is if you're trying to integrate this one into your package. So let me show you how to do that. They run and then I'm going to go. Okay, it's done. So again, this is the one here low left. This is the one on the right. Doesn't have a layer control. That's why you turn the layer on and off. But assume that this is something you are interested in. So you want to add a function to your map class. So the user can just give a URL and then give a bounding box and then you add that. So user don't have to worry to think about like what's the image overlay class or something like that. They don't have to worry about that. So in your source code, you can handle that. So for me, I would go to, again, my package. And then I can add just under the map class, right? So previously I have add raster. This one right now, I'm going to remove this because it's not working for now. So I can add a new function or new methods to the map class. So here, let's do this, map df, and then you can give a function name. Okay, Gap compiler is not good this time. Okay, I'm not trying to add a WMS. I'm going to maybe add image, for example. Okay, so I'm going to add an image to the map, and okay, yeah, all right, pretty good. So look at this one, like blah blah, add image. Oh, this one need to be indented. So in order to the map class, give me the URL, give me the bounding box. Oh, okay, it's done. And then we can also give a layer name and some additional keyword arguments. So this basically allows the user to specify anything. It's going to pass into this image overlay class. Sometimes it's required, sometimes it's not. So it depends on, yeah. So this one certainly has this one here. So you can pass in anything. It supports the URL, the bounding box, the attribute. Yeah, this one is duplicate, so they basically a bug. It doesn't need this one. But I can certainly have this URL bounds and also the attribute. So then we can come back to here, right? Look at this one, image overlay, and give the URL, the bounds, name, and then just add the layer. Yeah, pretty much that's it. So now the user can just call this map.addImage function to add an image to the map. So let's go back to this one to test it. So let me read the output, restart the kernel. So it's not too long, and I'm going to add a new code block. Right, so now we can just import your name of your package. Okay, on it, and then you can just do the same thing. Okay, so map. So usually I recommend just create a map first, because without that sometimes the auto completion doesn't work. So if you create a variable name and then you go back, it will usually will be easier. So for example, right now, let's just try this one. Okay, so we create an empty map, and then once you have this one, then we can use this. Okay, so you can define a variable and then define the bounding box. So let me copy these two lines, and then come here. Paste. Of course, you need to unindent it. Okay, and once you have this one, then we can call the method map.add. Doesn't come out image. Take a look, right? Now we can call this function map.addImage, and pass in the URL, the bounding box, and then that's it. Okay, everything else is you can use default settings. Let's see if this works. Oops, you have some error, blah blah. The URL or trail image must expect a Unicode. No, the tuple. Oh. File, blah blah. Oh, because I have a comma here, sorry. Yeah, if you put a comma at the end, it's going to treat that one as a tuple, and that's why it doesn't work. sometimes this previous step you need to be careful. Okay, now I have this one. And add it to the map. So this is the lower left corner, upper right corner. You can certainly change it, but let's add a layer control so that you can turn the layer on and off. So the m dot add layer control. Okay, on this one again, and you can see I have this one here. I can turn the layer on and off. And usually I would like, for example, for my map to be able to use the scroll. Right now the button, it doesn't work. So I would do it here. I will go back to my map class. So by default, I want to enable the scroll view zoom. So here, let me show you. I'm going to maybe add another tab in here. I would say if double quotes scroll view zoom is not in this one, scroll view. So what this one is doing, if you don't provide this parameter, I'm going to set this one to true. So it ain't going to pass into the maps, enable that. So this essentially will be like this one. So let me show you here. It will be similar to this one. Right. So now we have this map. Pay attention, right? If I use my scroll bar, it's going to scroll this up and down. But if you want to enable that, you'll be map.scroll ROLL zoom equal to 2. Do this one again. Try not see my mouse. Right. So usually I like this one, and that's why I enable it by default. So right now, even if I don't turn on this one. So if I restart my kernel, run again, the map should be able to actually allow you to scroll them. Okay, so try again. Look at this. Boom. So that means, okay, when I create a map, if I don't specify this one, you'll be true by default. But if sometimes you don't want it, you can disable it. So what you can do is come here. You can scroll, view zoom. Okay. SCROL view zoom equal to false. You can certainly do this one equal to false. That means you can explicitly disable it if you don't need it. Then in this way, okay, it's not working anymore. So this is how you specify default parameters. And you don't have to write it out. It's up to you. You can also write somewhere in here, like scroll, view, zoom, just like the zoom level. You can set it if you want to, but sometimes you don't want to be overwhelming because you might end up with like a lot of parameters specified here. You can just in your source code saying that, okay, if you don't specify, I'm gonna say that it's true, but you specify, I'm gonna use whatever you specify. You can specify it's true, you can specify it's false. And this is why in here, when I specify it's false, it doesn't work. But if I specify it's true, then you enable it. So now I can zoom in and zoom out. But usually, if it's something that you use commonly, then I don't need to specify. It's just in your source code. Right? So if you want to change it, for example, right now this is like negative 130 to 32 and then negative 100. You can do the switch. For example, this can be, I can change this one to maybe 100. This will be, it's going to move to the east. This one maybe 130. Can I do that? So pay attention to the map. See where it's going to move. I say it's coming here. It's not good. Oh, 13,000. Sorry. Like this. See? Now it's moved this one. But of course, this is the United States, right? So you need to have the clock the location here. But this can become very challenging because if you get any non-geospatial image, you need to figure out the latitude and the longitude itself, because this one itself is just a PNG. So PNG doesn't really have any information. So so the image overlay allows you to do something like this, but you can also, I think, overlay a GIF animation. So if you have a GIF animation, you can do that. So let me see. Okay, 20 GIF. So it's like how you can add the GIF animation to the map. And let's see if this one still works. Again, you will need to get the direct URLs. Okay, without the direct URL, it doesn't work. So close this one. This copy GF link, and then I'm going to say oops, doesn't work very well. Where did GF copy GF link? Let me see if this is a direct link or not. Yeah, this one may or may not. I'm not quite sure, but we can try it, right? So let me copy this URL, and then I can come back to here. So ideally, it should work. It may or may not, because if it is not a direct URL, it will not work. Let me run this one. Ah, yeah, not so bad, man. It actually works, but you see the orientation, the aspect is changed. So you will need to actually to figure out where you want to put it. So this is probably a little bit too small, right? Lower left and then upper right. So probably to increase this one a little bit, right? Depends on the kind of ratio. Right now it's too narrow, right? The ratio this is more like a square. So probably to increase this one a little bit, maybe from 30 to how about 50. You need to test it. There's not a perfect because this is too much. So maybe 45, right? A little bit better. Okay. So if you want to create some packages, you want to create some map, you want to put some funny face on there, okay? And as you can see here, it's only like 2 lines of code. But this is only for non-geospatial data. Usually we want to plot some raster images, GeoTIFF, then it's a different way. But for now, let's assume, okay, yeah, this just works. So this is shows you how to add an image. Try it out, see how it works. And the next one to show you is actually to add geospatial data, add real raster image, so that I don't have to figure out the bounding boxes. It should be automated, because if you have geospatial data, it has the coordinate information in that. So when you load the image, it should automatically figure out where it should be plotted automatically. And this is where IPyLive it doesn't have the functionality. So as I mentioned, IPyLive they have some of those like visualize vector data, and some of these mostly vector data, points, circle, and other stuff. And also the tile layer. A tile layer is already basically you need a web server to serve the tiles. But if you only have a GeoTIFF, right? How to actually put the GeoTIFF on the map? So there's another package that we're going to cover in this lecture. So you may or may not have heard about it before. So it's called Localtileserver. Might be difficult to see. Localtileserver. So if you Google it, you'll be able to find it. I think I also put it on our website, the link. And this is a package. It's pretty new. I think it's only like maybe 2 years ago. But it's very powerful for visualizing all kind of raster data. And you will need to install this one on your environment. So previously, if you've already installed a package, you don't need to try again. But usually I can just type, for example, Anaconda prompt. And let me show you how to install it. Okay. So previously we already use create a conda environment. So I will just conda activate, right? Geo to activate the conda environment. And after that, you can use conda or you can use Mamba. Assume that you already have Mamba, so I'm going to use type Mamba install -c conda force local high server. What? Oh, what I did. Oh, okay. My computer has problems. So this just remind me. If you just type that line on your computer, it's work. For me, it's a little bit annoying. I will have to go into my users and I see under my name here conda. It's under mini conda. Sorry, under my username, conda. Again, you don't need to follow me. Just my computer messed up. So conda with EMVH. This is where it's being stored. So under the scripts directory, there's a Mamba somewhere here. yeah. So I will need to come to here, open my terminal, and then do the same thing here. So again, if you haven't installed conda, activate geo, and then so for me it will be this mamba. So exe, this one should work. Yeah, and then mamba install. -c conda first Localtileserver. So you just type mamba install Localtileserver, and then from the conda first channel, you should be able to install that package. If you have done that a long time ago, you might want to upgrade because there was some major changes during the last month or two. So you might not have the latest version. If we install already previously, yeah. So just install it, and then we should be ready to go. And after that, you can come here, show you how to like try out the example. So what you can do is just to maybe go to the website. So click this one on the home page. Go to the website here, documentation, and you will take you to documentation. The documentation has some examples. So see this one, right? The map is actually interactive. So it's pretty nice. Basically, you can build a website. You can load some raster data, and then you can even see that interactively here on your website. So it's pretty cool. But it's different from the one that we use for our documentation, the MK docs. It's different mechanism, but it should work very similarly. So what you can try is just copy this example. You notice in here, they're also using IPyLeaflet. Create a map, and then create a so-called tile client. A tile client basically you need to have a client, a server, and then you basically grab the tiles from the server. It's a bit complicated, but you don't need to worry too much. Just copy the source code, and then we're gonna show you how to integrate this one into the package. So again, come to this one, and then let me restart my kernel. I'll remove everything, and from here just paste. So if you already have the package installed, then you can just run it, see if it works. Okay. And let me come back to here. This install. No. Yeah, my computer is very slow. But if you run this one, the package, if it's installed, you should be able to see the map. And this might be a little bit slower on my computer, but I hope it doesn't take too long on your computer. And you see it's buffering. So behind the scene is actually creating the server, and then use the server. So this is why I call Localtileserver, because IPyLeaflet can only handle the URL. So basically, giving you a tile URL. So this tile server basically generates the tile URL for you to use. If you really want to test it, for example, see what's behind the scene, you can create a new code block and just type m.layers. And look at this one. So under the hood is still a tile layer, but it's a long URL. So for example, you come here, go to the right, look at this one. So there's a local server running on your computer, and then using this like port number, tile XYZ, the file name, blah, blah, blah. So this one here is actually, this is where the tile is being hosted. When you open the link, it probably doesn't work. You cannot get access to it. But behind the scene, this is how it's being accessed. So basically you have a computer server. It's the same server that we're using, and then it is creating the tile. So whenever so IPyLeaf basically accessing the server, and you send the request, and the request will generate the tile for it to pass it back to the client. And for example here, you can zoom in, you can zoom out. So depending on how good is the computer, you might see some buffering, but this is pretty nice. So you notice here, I don't need to specify the bounding box. Of course, here, I think it specify, yeah, it doesn't specify the zoom, the client default zoom, and also the client default center. So this one here, we don't need to hard code it the number. We just, basically the tile client store the information about the map size, the center, the zoom level. So this client here, if you want to access it, you can create a new code block, and you can just type, for example, client dot, right, center, and run it. Oh, it's a measure, so you need to print his parentheses. So basically, you're getting this information indirectly, and then you're passing into the map. So in that way, you don't have to hard code it, right? You give me any image, I'm going to use this client to create the Localtileserver to create a client, and then you can grab the center and the zoom label. Similarly, right? Client.zoom. And oh no, zoom. Or default zoom. Okay. No. Or default here. Default. Anyway, so right zoom label default is 9. So this is how you can access the information. And again, look at the source code. Right? We don't need to specify. We don't need to hard code it. If you don't have this one, when you create a map, if you don't specify this one, you can also use the map.center. So let me show you. Assume, right? You create the tile server and then you create a map and then add the map. If you just do it like this, if we're going to create a global map and it doesn't show you actually the location. So you will have to zoom all the way out just to see it. And I know the image is around San Francisco, right? So you see somewhere here, and you need to zoom in. Right. So when you create the map, you can either specify the zoom in the center. If you don't, you can do it like this. I can do it map.center equal to, again, not good, okay? Giga Copilot is not good. Give me the numbers. I don't want the numbers. I want you to get the number automatically from the previous one. So you'll be, from the client, you'll be client.center. Okay, parentheses. Yeah, there's parentheses in here. And then I can also do m.zoom equal to client dot default zoom. Okay, something like this. So you can create the map first, and then once you add the data, and then zoom to the location and add the data layer, or you can add the data layer first and then zoom to it. So you'll be like this, right? So now if I run this one, take a look. It should center around automatically. Make sense? So it's so much better than if you don't specify like this. Not good, okay? Because users don't, if this image is very small, it's very hard to tell. But the nice thing about this, it's not hard coded, okay? So this is not hard coded. You don't see the number. The number is based on the image that you use. Make sense? So with this one, you can do it for any images. So for example, you're going to show you another code example, client equal to type client, pass to geotiff. So that means you can pass any images. So now let me show you, right, how to get some data. So this one allows you to visualize any data in the cloud. You don't even need to have the images on a local computer. So let me show you, like, how do I get some images? I'm going to go to my GitHub repo, and I'm going to grab some images. So under my GitHub repo, there's a datasets. I have some sample datasets stored on GitHub. Under the releases, so this is where I store all kind of sample datasets. So it's under the raster here, for example, right? Some assets. So here I have some DM, I have some others. So for example, I want maybe this one, SRTM 90. Okay. So all I need to do, just right click and then copy linked address, because this is a direct link. So if I click this one, it should ask you to download this one to a computer. So you're certainly welcome to download it to your computer if you want to, right? Let me try download it and see how it goes. So I have this one images right now on my computer here. So I can actually uncomment this one. So the client right now can actually use it. Earlier we used the sample data, but now we can actually use the images that I downloaded. So it'd be SRTM 90, okay? So it's a DM, right? And pay attention to here. I don't need to worry about the zoom and the center. I think it should work just fine. So if I execute this one, see? I don't make any changes. It loads the data layer, it zooms to this automatically. Super nice. And also when you create a type client, I think there's a parameter called color map. Let me see here. I can add a color map. So color map equal to, I know this is DM, so I can actually use the terrain, right? So the map probably color map. So oops, color map. Oh, here it's this one, not there, not the type client. It's the get tile layer. So here, if I type this one, color map equal to terrain, and run this one. Huh? Color map. Or maybe called CMap. Probably CMap, no color maps. CMap. Okay. And how nice, right? Just one line of code. You need to see the parameters name here, hover your mouse, and there are lots of those like band. It's called palettes. I think this is the older version. So the new version is called CMap. So you just use the CMap, it should work. And with this, now you can analyze, you can actually visualize any raster data. So this one right now, we're using the one locally. But as I mentioned, you can directly pass the HTTP URL. You don't need to download the data. So for me, I can just copy this one, copy the link URL, then come back to here, do the same thing. I can say client equal to tile client, and then parentheses, double quotes, HTTP URL. So look at this one. I'm going to comment out the previous one. So right now, I'm just giving the URL directly to the image, the program, and let's see if it works. It might take some time because you're going to do the tiling, but see, how nice. So now you can access, visualize any images in the either locally or in the cloud. It doesn't matter, right? And the image can be many gigabytes. It can be a very big image. It can still visualize. And so let me see if I can show you an example. There's a big image. I don't. This is still pretty small. But let me go to leaf map. I think I have some like large images that can show you how big it is. So I'm gonna go to maybe the cloud optimized GeoTIFF somewhere here. For example, this one. Oh, not this one. I think probably I already changed it. Maybe it's under some links that use. Is it? It real F hot. Okay, so optimize. Yeah, I think I already updated it. So I already removed those last one. Anyway, oh, I remember now. Where can I find this one? The book. Under the local raster data. Here should be visualizing plots. Yeah, this one. Go see. This is the URL that pointing to a large data set. And again, I can try to download it. This is a big data set. So see here, 2.9 gigabyte. It's going to take some time. Here, full download history. And look at this. 1 minute left. 0.9 gigabyte. It's too big. I don't want to download it. So for me, I can just come here. Let me see if I can copy the URL. But here, right click, copy the link address. So right now I'm accessing the direct URL. But let me cancel this one for now. Pause. And let me paste this URL again, right? It's from Digital Globe. Long URL. Again, if you want to try it out, let me put this one on the website. So if you want, you can just copy the link, so you don't have to spend time trying to search and navigate it. I'm going to put it under the resources. Here, data repository. Supposed to be edited. file. Why is no? Anyway, so let me go to my repo. I'm going to share this one with you so you can try it out on your repo. So let me go to my repo. I'm going to put it under the discussions. And so here I want to create a new one. You can come here just to grab it. So it would be general, then sample data set. Okay. Just going to create this one here. Okay, up to you. If you want to grab that, you can come here to get images. I can also maybe add another one here. Raster. So these are some of the sample raster data set you can get to test your algorithm. What time is it now? Okay, so we have 30 minutes. We should be able to. So for the first one I'm showing, right? I showed you earlier. This one is 2.9 gigabyte. It's pretty big. You can download your computer, but we can actually use it directly within here. So very simple. Come here, and then, or let me create a new one. I can keep this one. And say client equal to hi client, and then pass in the URL, the long one. In order to visualize that, you cannot use the color map, okay? So because this is a multi-spectral image, color map can only apply to a single band image. For multi-band, you don't want to use the color map because it doesn't make sense. So right now, what we're doing is pointing to this image. And again, this image is 2.9 gigabyte. Take a look. It's going to buffer a little bit, but it should be much faster than you trying to download 2.9 gigabytes. So it's basically just to talk to the image. And because that one is hosted in the cloud, it's going to do the so-called tidying. And after that, you should be able to see the images. It's a bit slower here on my computer, but in general, it should be within a couple of seconds, you should be able to see the image. Let's wait for it to load. And so next, let me show you how you can actually integrate this one into your package so that you can have just one line, and then user can just use it to add raster without having to like import the Thai client, get the Thai layer, and then the Thai client, and then get the center, default zoom, or something like that. I want it to be simple, just one line. Okay, it's a bit slow, but let me show you first. I'm going to go to my package here. Then we can start doing the integration. Okay, so what I'm going to do is to come to the bottom here. I'm going to add a new function. So I'm going to maybe df add raster. And in the raster here, you can pass in parameters similar to what we do for the add image. But for this one, yeah, let me accept this one for now. But I don't like any of this, okay? Because it's not going to work. So what I want to do is actually using the this is a bit slower than I expected. Anyway, never mind. First, let's do this. So all I need to do is to copy this too. So from IPy Localtileserver, we import this one, and then we can create the Thai client, get the Thai layer, blah blah, and then create a center. So what we need to do is to come to this one and paste this because you need to import it. And before you import it, so in general, this is a new dependency. So you probably need to put this one into the requirement of txt. But keep that in mind because Localtileserver depends on other packages. If you put in here, it might not be able to install on all the operating system. So you can certainly try, but some of the dependencies just doesn't work on all the stuff. So instead of adding this as a required dependency, I usually just come here, let the user install it. So what you can do is basically you can try like say try except, and then you can say import local Thai server blah blah in here. Maybe this line, okay. So you're going to do this one, and if it doesn't work, you can say except import error. Then you can give a notification, raise import error. Please install local Thai server package. So if the user doesn't install this one, it's going to break it. So then the user can install themselves, depends on the operating system. So always keep in mind, if you need to add a new dependency to your package, think twice. If there's a simple one, you can add that, it's fine. But complicated one that doesn't work on Windows, Mac, or Linux, then you don't want to add it. So once you import it, then we can start doing this one, okay? Client equal to the type client data, because if you give an image, I want to create a type client, and then you want to get the center, get the zoom, and blah blah, something like that. So once you have this one, you can get the layer, okay? Yeah, just like this one. And also here we have a bunch of data layers in here. So what you want to do is to actually pass the name, for example, name equal to name, and then you can pass in any additional parameters. So whatever you provide in the function, I'm going to pass in into the layer. So in that way, you can specify the color map, you can specify the band, or anything you like. And once you have this, then you can do this. You can just self.add layer. Okay. So let me show you, like, you can do the comparison with your source code that we did earlier. Go to the notebook. It's still loading. This is a bit abnormal. Let's use the smaller one as an example. There might be something wrong that I need to. Okay. Let's use the DM example. Faster. So look at this one, right? Okay, whatever. So look at it here. This is what we are. Why the client see here? Right, so we import the library, and then we create the client based on the data. So this data can be a file path locally. It can be something to the HTTP URL. And then we get the type layer. Of course, the type layer right now, we don't add any additional parameters, but because the type layer support many other things, right? So you want the user to be able to use this. The easiest way is just to pass in this ** keyword arguments. That means it's unlimited. You can provide anything. I'm going to give it directly to the function. And then we create the map. Of course, here we don't need to create a map because we are under the map class. So you don't need to create a map again. The map is already being handled. So what we're doing here is just to add this layer. And there are two more parameters in here. So these two allows you to zoom to the layer and then center it and also do the zoom level. So usually what I would do would be like this. Okay, you can add another parameters. Let the user allow to decide whether to zoom to the layer or not. If you don't want to zoom to the layer, fine, I don't use it. If otherwise, by default, I'm going to zoom to the data layer. So what we can do here, I can add another parameter. It will be like zoom to layer equal to true. Okay, so that means this is the default behavior I want to have. And then you'll be like this. Okay, if you want to zoom to the layer, okay, then you'll be save dot center equal to the client dot center. Okay, and then save dot zoom equal to the client dot default zoom. That's it. So that means user can decide whether or not they want to zoom to a layer. By default, it will be true, but you can turn it off. Make sense? Now let's test it. See if it works. Okay. So let me come back to my notebook, and we can use the same thing, the same source code in here. Let me create a new code block. Okay. So you'll be import COA. Okay. Like I said, I always just create this new map first. Dot map, and then just display it so they can use the auto completion. So right now this is the map, right? So I'm going to add some raster data, and of course first you need to add the URL. So pay attention to here. Right now user don't have to know the type client. All they need is just give me a file path. So maybe let's try this one. Use the local file path first. So I can do it like this. Say data equal to srtm90.tif. Right. So this is the file on my local computer. And then with that, I can just m.add raster, you see, create intelligence. So let's see, by default, it should be able to zoom to the data layer automatically. Oops, what happened? Int Oh, okay, default int, so it's not a parenthesis. This is a bit annoying. The center you will need a parenthesis. This one you don't have, you don't need to, because it's already a number. Okay, so I'm going to save it. Then come here, restart. Clear the output. You need to restart, otherwise, oops, it probably doesn't work. Okay, restart. Then import this one. Okay, run it. Hopefully it works. And see how simplified right now. 2 lines of code compared to you need to import the library, you need to define the type client, and then you need to set the zoom and the center. It should be much more simplified right now. And it's so much easier to use rather than you have to know many other packages. This is how you build, you see? How nice? Zoom in, I can zoom out, that's it. And if you don't want to like zoom to the layer, yeah, fine. If you have multiple data layers, sometimes the user might want to have the map view center here. If you add more layers, I don't want you to automatically zoom. You can do that as well. So I can here just turn this one off. It will be zoom to layer equal to false. So that means by default, I'm creating a map center around the US. It will stay like that. It will not zoom to the raster data layer. So if I run this one again, okay, you don't see it because I don't zoom to it. But it's here if you can find, if you want to find it, right? Of course, you can set to true. It's going to use true, but the true is the default parameters, so it doesn't really, you don't need to specify it. You can just keep it as the default one. And like I said, nice thing about this is all the parameters that I'm providing can be passing back to the program to get type there. So in this case, I can just specify cmap equal to string, run it. Okay. I now have this one. And of course, I can also add the layer control. So if you want to turn the layer on or off, it will be m.add layers control. Run it. Yeah. Okay. Out. And the layer here, right now, this is so-called the raster, but you can customize it because in the source code, so by default, it's called raster. I can change it to something else. I can come back to here, and then I can just say name equal to DM, for example. Want it? And this one, now it's DM. Right? And you can zoom, you can turn the layer on and off, up to you what you want. So here for this the layer, let me show you. For example, m.dot layers -1 is that we are accessing the tile layer. Oops, in this URL. This is basically under the hood is the URL on your local tile server. You can also interact with it because it's let's show you this, if this works or not. Paste like this. Yeah, it may or may not work. Let me see. Okay, and take a look at the layer above. We haven't covered this yet. This is called iPie widget. So anything you add to the map is a widget that you can actually interact with. So we are changing the opacity, right? Pretty cool. Let me remove this one so they can see it clearly, right? So I'm acting a slider, the map, that allow the user to change it interactively. Right now it's separate, but later this semester I'm going to show you how we can add a button somewhere, add a slider at the map, and change the slider, and change the opacity. But at least right now, you can visualize any raster data layer, either it's locally or in the cloud. Same thing here, right? Right now, this is using local file path, but I can just use this one. It's work the same way. Let me copy this one. Come back to here. Replace this one. Copy. Paste. That's fine. Okay, so try it out. And if any question, let me know. Yes. Here. Oh, -1 basically the last one, the last data layer. So basically indexing, because when we type m.layers, think about here, it's a tuple, right? Have two data layer, tile layer, bound tile layer. So this one is local tile server. So -1 basically get from the end, right? Or you can just use m layers 1 is work as well, because layer 0 is this one. This is layer 1. Or it can be layer, this is -1, this is -2. Make sense? So it's the same thing. For example, if I change this one to m.layer 0, that means right now we are changing the base map, right? The OpenStreetMap. So if I run this one, pay attention. It's the same thing, but if you pay attention to the one at the bottom, you see that? So everything is like widget. It's very, very powerful, very flexible. We cover this one maybe in the next lecture about how to add the widget. But right now, you should be able to visualize some raster data, some vector data, and then you can do all kind of stuff. So this is essentially what Gmap and LeafMap was built on top, is to allow you to visualize this thing. Okay, so that's all for today.